All right, let's dive into one of the most foundational and honestly, one of the most important pieces of Amazon Web Services, the Virtual Private Cloud, or VPC. Now, I know it sounds super complex, but trust me, by the end of this, you'll see it's all about carving out your own private, super secure space inside the giant universe of the AWS cloud. So let's break it down. So here's what we're going to cover. First, we'll get a real handle on what a VPC actually is. Then we'll talk about the why. You know, control and security. After that, we'll get into the fun stuff, laying the foundation, directing traffic, setting up your virtual security system, and finally, connecting that private cloud of yours to the rest of the world. Okay, first things first, let's really get to the heart of the problem that a VPC is built to solve. Think about it like this. AWS is this massive open landscape. It's public. You want to build all your cool applications there, but you can't just leave them out in the open for everyone to see, right? You need walls, you need gates, you need your own private address. So, the big question is, how do you build a secure fortress in a shared space like that? Well, the answer is a VPC. And honestly, the best way to wrap your head around it is to think of it as your own private data center, just virtual. It's your own little slice of the AWS cloud, totally isolated and dedicated just to your account. You get to control everything inside it, from the IP addresses all the way down to who gets in and who gets out. And that brings us perfectly to the why. Why even bother with this? A VPC isn't just some nice-to-have feature, it's the absolute bedrock of any serious cloud setup. Let's look at the core benefits. There are three massive reasons you're going to use a VPC. First up, isolation and security. It's simple. Your stuff is walled off from everybody else on AWS. Second, network customization. You are the architect. You get to design the network exactly the way you need it to be. And third, hybrid connectivity. A VPC is the essential bridge that securely connects your cloud resources back to your own company's data centers. So those big ideas translate into some really powerful, practical advantages. You get granular control, meaning you can define with surgical precision who and what can access your applications. You get layered security, so you can create a real defense-in-depth strategy. Think public web servers in one area and super-sensitive databases locked away in another. And you get all this while tapping into the incredible scalability of the AWS cloud. All right, enough theory. Let's get our hands dirty and actually start building this thing. The very first step to creating a VPC is to draw up the blueprint for your network. Every building project starts with defining the property line, right? In a VPC, that's called the CIDR block. Just think of it as your plot of land in the AWS cloud. It defines the total pool of IP addresses your network can ever use. A really common choice gives you over 65,000 addresses. So you can see why planning this out from the start is so important. You don't want to run out of space later. So you've got your plot of land. The next step is to divide it up into different areas for different purposes. And that is exactly what subnets are. A subnet is just a smaller piece of your VPC's address range, and it lives inside a single AWS data center, or what they call an availability zone. If the CIDR block is your land, subnets are the individual rooms you're building. This is where your resources, your servers, your databases are actually going to live. And here's a super important point. Not all rooms are created equal. You have public subnets and private subnets. The difference is dead simple, but it is absolutely critical. A public subnet has a direct path out to the internet. A private one doesn't. So you'd put your web servers in a public subnet so your customers can find you, but you'd lock your precious databases away in a private subnet, totally shielded from the public internet. Okay, we've built our rooms. Now we need to define how data moves between them and how it gets to the outside world. It's time to set up the rules of the road. And this is the job of the route table. It's basically the GPS for your network. Anytime a packet of data tries to leave a subnet, the route table looks at where it's trying to go and says, aha, you need to go this way. Every single subnet you create has to have a route table associated with it. No exceptions. So, how does that web server in our public subnet actually talk to the internet? Let's follow the path. It's a simple three-step journey. Traffic leaves the server and hits the subnet's route table. The route table has a special rule that basically says, hey, anything trying to get to the internet, you need to go to the Internet Gateway, or IGW. And that IGW is basically the big front door of your VPC that opens up to the public internet. But what about our resources stuck in the private subnet? What if your database server desperately needs to download a security patch? It can't use the main internet gateway. And that's where the NAT gateway comes into play. It's this brilliant, secure, one-way door. It lets your private instances go out to the internet to grab things like updates, but, and this is the key part, it completely blocks the internet from ever starting a connection coming in. Now let's really zoom in on security. A VPC gives you two really powerful layers of defense to protect everything inside. I want you to think of it like a complete security system, with personal bodyguards at every door and giant fences around the whole property. Those two layers are called security groups in network ECLs. Security groups act at the instance level. They're like that dedicated security guard standing right at the door of each individual server. Network ACLs, on the other hand, they work at the subnet level. They're the big fence around the entire neighborhood. So for traffic to get to your server, it has to get past the fence first, and then it has to get past the guard at the door. And this brings us to the single most important difference you have to remember between them: state. Security groups are stateful. They're smart. If you let a request come in, the guard automatically knows to let the response go back out. It's common sense. But network ACLs are stateless. They're dumb as a fence post. They don't remember anything. You have to create one rule to let traffic in and a totally separate rule to let the response go back out. Understanding that distinction is absolutely key. All right, last piece of the puzzle. Your private cloud is amazing, but it rarely exists on an island. You're almost always going to need to build bridges to connect it with other networks, whether that's other VPCs or your own company's physical data center. And AWS gives you a whole toolkit for this. For example, there's VPC peering to link two VPCs together. There are VPC endpoints that let you talk to AWS services like S3 privately without ever touching the public internet. A virtual private gateway is your ticket to creating a secure VPN to your on-premise network. And for the really complex setups, the Transit Gateway acts like a central airport hub, making it way easier to manage tons of connections. So as we wrap up here, I want you to remember this number: 2. Every well-designed VPC is built on these two fundamental layers of security. You have the subnet level fence, that's the network ACL, and you have the instance level guard, the security group. Using both together is how you build that critical defense in depth. And when you step back, that's really the big picture here. That's the magic of a VPC. It gives you the best of both worlds. You get all the granular control, all the security, and all the familiar networking ideas of a traditional data center, but you get it with the mind-blowing scalability and flexibility of the AWS cloud. So, you now have the blueprint. You can create your own secure, your own scalable, your own powerful corner of the cloud. The foundation is yours to command. The only question left is, what amazing things are you going to build on it?